Hi all, welcome to day 10, which is solved by factoring. So far we've solved and we've factored, but now we're going to put them both together. We've solved by graphing. So you graphed the parabola on your graphing calculator and saw where the parabola crossed the x-axis, or where y was 0. Sometimes you got 1 point, sometimes you got 2 points, or sometimes there was no real solution. We were looking for the points where y was equal to 0. Now we're going to solve by factoring. Again, we're going to find the points where y is equal to 0. Here's the zero product property. This one's important, so you're going to want to write it down. The zero product property says that if a multiplied by b is equal to 0, then either a is 0, b is 0, or both a and b are 0. This makes sense. If you multiply two numbers and their product is 0, one of those numbers has to be 0. In this example we have here, this is like our a, this is like our b. When you multiply them, you get 0. Because of that, either x add 3 is equal to 0, or x subtract 5 is equal to 0. Solving the first equation for x, I get x equals negative 3, or x equals 5. As when we solved by graphing, your solutions need to be written as ordered pairs. So the first one is negative 3, 0. The second one is 5, 0. Remember, we're looking for the points where y is equal to 0. So your solutions are always going to have y equal to 0. This example was already factored for us, and the next two we're going to have to do the factoring. One important point before we move on, the zero product property only applies when your equation is equal to 0. If it's equal to any other number besides 0, you're not going to use the same process. Moving on. Here are the two examples. So we're going to start by factoring. First example, I want to find the GCF of 35x squared and negative 15x. The greatest common factor is 5x. When I factor out of 5x, I'm left with 7x subtract 3. This is set equal to 0, which I just told you it had to be, so we're good. We can use the zero product property. That means that 5x is equal to 0, or 7x subtract 3 is equal to 0. Solving the first equation, you divide by 5, you get x is equal to 0. Second equation, add 3 and divide by 7, you get x is equal to 3 over 7. Last step is to write our solutions as ordered pairs. The first one is x, comma, y is always going to be 0. Second one is 3/7, and again, y is equal to 0. Okay, second equation is equal to 24. Has to be equal to 0. So first thing, we want to make this equal to 0. Subtract 24 from both sides. You get 3x squared. Add 6x. Subtract 24 is equal to 0. Now in order to factor, I'm going to factor out the GCF, which is 3. So I have x squared, add 2x, subtract 8 is equal to 0. So I'm looking for two numbers whose product is negative 8 and whose sum is 2. Those numbers are positive 4 and negative 2. Positive 4 multiplied by negative 2 is negative 8. They add to be positive 2. Bring down the 3 that you factored out. Now we're going to use this zero product property and set all three parts equal to 0. So either 3 is equal to 0, which does not make sense, x add 4 is equal to 0, or x subtract 2 is equal to 0. Solving the first equation, I get x is equal to negative 4. Second one, x equals 2. So my solutions become negative 4, 0, and 2, 0. Something to note, both examples we had x squared, so the squared was our highest power and we got two solutions. Whatever the highest power is, that's how many solutions you should have. Sometimes they're going to be the same point. You know, you're in a factor and get the same point twice, but that's kind of a hint as to how many solutions you should have. Now we're going to go in the reverse direction. I'm going to give you the solutions, and you're going to write the equation. So here's the first example. Write a quadratic equation in standard form with 2 and 5 as its roots. That gives us x subtract 2, x subtract 5 is equal to 0. So let's check. If I set x subtract 2 equal to 0, I get x equals 2 as a root, which is what we were given. If I set x subtract 5 is equal to 0, I get x equals 5 as a root, which is what we were given. Now, this right here is not standard form. Standard form is the y equals ax squared add bx add c. So we need to multiply this out. X multiplied by x is x squared. X multiplied by negative 5 is negative 5x. Then we get negative 2x. Add 10 from negative 2 and negative 5. This is equal to 0. Combine your like terms, you get x squared, subtract 7x, add 10, and we want to set this equal to y. This is our final answer. Moving on, here are 2 more examples for us. First one, quadratic equation with 8 as its root. Quadratic already tells you x squared, so you should have 2 roots. But we were only given 1 root. That means 8 is a double root. So you're going to have x subtract 8. You're going to have x subtract 8 again. And that's equal to 0. So multiply, we get x squared. Subtract 8x. Subtract 8x again. Add 64. Combining like terms, the final equation becomes x squared, subtract 16x, add 64, and then remember to set the equal to y. Okay, last example of this type, and then we have 1 word problem. Our 2 roots are 3/4 and negative 5, so we have x subtract 3/4 and x add 5. Okay, standard form, you cannot have fractions like this. So because my denominator is 4, I'm going to multiply this first set of parentheses by 4. When I do that, I have 4x, denominators cancel, subtract 3. Second set of parentheses stays the same. Now I'm going to multiply out. 4x squared, add 20x, subtract 3x, subtract 15 is equal to 0. Combining like terms, 4x squared, add 17x, subtract 15 is equal to y, or is equal to f of x. That's function notation. We've used that before. So that's writing a quadratic equation given the roots. We're going to do 1 word problem, and then you guys have 2 to try on your own. So here's the word problem that we're going to do, and then, like I said, you have 2 on your own. Okay, given a rectangle, so draw yourself a rectangle with an area of 96 feet squared. The length is x, add 2. The width is x, subtract 2. Find the dimensions. In a rectangle, area is length multiplied by width. Our area is 96. The length is x, add 2. The width is x, subtract 2. Now, in order to use the zero product property, our equation has to be set equal to 0. It is not in this case. So I'm going to start by multiplying out this right side. So keep the 96. When you multiply the right side, you get x squared, subtract 4. We want to set this equal to 0, so subtract 96. You end up with x squared, subtract 100. Now I'm equal to 0, so I'm ready to factor. This is a difference of squares. Factors to be x subtract 10, x add 10. Solving both, I get x equals positive 10, I get x equals negative 10. In the context of our problem, negative 10 does not make sense. If I substitute negative 10 into the length and the width, I would get a negative answer. It doesn't make sense, so we're going to use x equals 10. The question asks us to find the dimensions. Substituting in 10, I get 12 feet for the length, and I get 8 feet for the width. So our rectangle is 12 feet by 8 feet. Here are two for you to try on your own. Right now, take a minute or two, pause the video, try them on your own, and come back. Welcome back. First example, you should have subtracted 72. Factoring, you get x subtract 9, x add 8. So then your solutions become 9, 0, and negative 8, 0. Second one, first root is 3, second root is 5. Multiplying out, you get x squared, add 2x, subtract 15, and set that either to equal to f of x or equal to y. So I hope those went well for you. Just to look back at what you guys just watched or what you just did, you now have two methods to solve. You can graph in order to find the points where y is equal to 0, or you can factor to find the points where y is equal to 0. Just make sure that your equation is always set equal to 0 before you factor.